So hello again. This is Roger Kochbar, Week 5, Segment 11. It's useful here to do a problem session that's about getting axial and membrane currents from a set of transmembrane potentials. You're going to be amazed at how easy this is. Here's our problem. We have a list that goes along the x-axis, and for each different x value, here's our list. We have sites along the x-axis. For each of our x values, we have a corresponding transmembrane potential, Vm. Now I have listed these Vms as values of Vm relative to the baseline. You could have them listed absolute. It isn't going to matter. The first question is, what is the sign of the intracellular axial current in each interval along the way? So the answer can be positive, negative, or zero. And the second question is, at each of the sites, 1 to 5, that is not at the ends, but all of the interior sites, what is the sign of the transmembrane current? It can be plus, minus, or zero. So I can tell you it is very useful here mentally to begin by drawing a sketch. And if we do that, in this case, we say what we have is it goes like this. These are the Vm values as a function of distance. Here's our distance axis. Here's our Vm axis. So I can look at that. I don't have to compute anything. I can look at that and say it's like this. This is where my currents are going. They're going nowhere in this segment right here. The axial currents, there are none. They're coming downhill in this segment over here. Or in this direction, I'd say they're like that. So they're all minus. In the third part, the part over here on the right-hand side, I'd say these currents are all going this way throughout this segment. They're going to the right. That is, as soon as you see the Vm curve, you know which way the currents are flowing. They flow downhill. I won't put in actual signs or numbers, but you can substitute them easily from the numbers in the list. I hope you'll do that. In the second part of the equation of this question, it asks, what is the sign of the transmembrane current? It can be plus or minus or zero. Let's again do the question graphically. It's really easier that way. I'll make my plot once again. So here's the plot. Here's Vm as a function of distance. Distance this way, Vm that way. And I say, where is their transmembrane current? So the way I want to do this is first I want to find the axial current. That's how the derivation went, and that's what I want to do again. So let me draw the axial current. No axial current here. Over in the next part, I have axial current that's flowing to the left. After I get to this peak, I have axial current that's flowing to the right. If I look at this, I know right away where the sources and sinks are. Right here, we have IM is positive. Because current flows into this junction, it's flowing in from the right, there's no current to the left, so it has to be outward. Up here I have IM negative. And I know that because I have current flowing away to the right, I have axial current flowing away to the right, I have axial current flowing away to the left. So my transmembrane current just has to be pouring in here. Just as it's going out there, it has to be pouring in here so that it can divide on the left side and the right side, and all the current loops can work as they should. Once again, I won't put in plus, minus, and zero, or compute numbers. I'll leave this up to you, but I hope that you will do so. Thanks for watching, and we'll move on now to a review of the week that we've just completed. Here's a picture of the Duke University clock tower, which is a famous campus landmark. You see the clock up there on the top of the tower. I think at one time the clock had a lot of functional value. People referred to the clock to tell the time. But nowadays, wristwatches are so inexpensive and so many people tell the time from their cell phone or some other way, the clock serves mainly as a decoration. An interesting campus story is that one time some undergraduate students who are experts in climbing climbed up that tower to the clock and put some big fancy gloves on each of the hands, sort of Mickey Mouse type hands. And it went around like that for a few days until the campus administration asked the students if they would please come back and take them off. And so they did. Thank you for watching.